On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at implicit differentiation, and this video is going to serve as an intro. And basically, when we're trying to find y prime, and later on in the course, you're going to have equations given to you implicitly. These are examples of equations where you are given y implicitly. Basically, you have some x's and some y's mixed together and you need to find the derivative. Well, this here is what we've been doing all along, and what I want to go ahead and do to motivate the idea, let's find the derivative of this real quick. So therefore we have y prime is equal to, doing our basic power rules here, pulling the 2 down times a half, that gives us 1. So we just have x plus this 5 here. That's the derivative of this parabola. Again, basic power rules. 2 times a half is an understood 1. We subtract 1 from our exponent, and the derivative of 5x is going to be 5. Also remember, the derivative of any constant is 0. Now, let's look at this function in a slightly different way. What I'm going to do here is I want to multiply everything by 2. So therefore I have 2y equals, multiplying this by 2, we have x squared plus 10x minus 6. So now, this looks a little bit different, but it's the exact same curve as what we have here. And I'm going to move the 2y over here, so therefore we have 0 equals x squared plus 10x minus 6 minus 2y. This is a moderate example of us having an equation that is implicitly defined. Now, it's very easy to get y by itself. If we were to reverse some of this stuff that we just did, we could go right back to here. But now, let's find this derivative. Let's find y prime, or dy dx. And what I want you to take note of is this piece here, and I'm going to explain what this stuff in red means. So if we find the derivative of this side, the derivative of 0 is going to be 0 because 0 is a constant. Same thing as what happened with this negative 3 over here. The derivative of a constant is 0. The derivative here is 2x. The derivative here is plus 10. The derivative of negative 6 is going to be 0. And then this piece here, the derivative of negative 2y. Take this derivative almost like you took the derivative of 10x and we said it was 10. The derivative of negative 2y is negative 2, but look at what it says up here in red. Tack on a y prime to any derivative term where you differentiate a y. We are differentiating a y here, so let's tack on a y prime. That's what I mean by this up here. Tack on a y prime to any derivative term where you differentiate a y. Now, let's get y prime by itself and let's see what our final answer is. So to get y prime by itself, I'm going to move this negative 2y prime over here by adding. Therefore, we have 2y prime is equal to 2x plus 10. Getting y prime by itself, we divide by 2, all terms that is. So therefore, y prime is equal to x plus 5. Notice we get the exact same answer as what we got over here. So what do I mean by really we have been doing this all along, sort of? Well, when we had y equals this stuff, automatically out of habit we just write y prime. Well, really what we're doing there is we're taking the derivative of y with respect to x. The derivative of y is 1, but we're really tacking on a y prime. That's never probably been explained to you, but out of habit we just say if y equals this, then y prime, we take the derivative. Now, that can become more important when you take derivatives of things where you can't get y by itself. Now, technically we could get y by itself in this equation of a circle, x squared plus y squared equals 25. That is the equation of a circle with a center at 0 and a radius of 5. But if we want to find the derivative of this without getting y by itself, because that would involve us taking a square root eventually, we can now use what's called implicit differentiation. So let's do that here. X squared plus y squared equals 25, and we want to find dy dx, or y prime. It's the same thing. So therefore, when we find the derivative of this, the derivative of x squared is going to be 2x. The derivative of y squared is 2y, but now we want to tack on that y prime. So simply just write it right after you take that derivative. We're really multiplying by that, and this is going to be equal to not 25. The derivative of 25 is going to be 0. Now let's just work on getting y prime by itself. All we have to do to get this y prime by itself, First, I would move this 2x over here to this side, so therefore we have 2y, y prime is equal to negative 2x once we move that 2x over here. Let's divide by 2y, so therefore we have y prime is equal to negative 2x over 2y. Simplifying this down, y prime is equal to negative x over y. And it's totally fine, and you'll oftentimes find that you'll have derivatives using implicit differentiation. Your y prime will have a y somewhere in its derivative. As you can see, it does right here. That's totally fine. You'll run across several examples like this. But now, with this idea, you have to remember product rule, chain rule. Technically, chain rule is what we're really doing here when we tack on the y prime. Quotient rule, power rule, product rule, all these things still combine together. And then in a future video, we will look at an example like this. That's this sideways oval where we want to come and find some equations of tangent lines. Now that can get real interesting because you can have more than one tangent line for a particular value of x. But more on that later. But the main thing here is this. For now, the intro to implicit differentiation, when you take the derivative of something that has a y in it, for example, here to here, tack on that y prime, and then ultimately you're going to be working on getting y prime by itself. In a future video, we will explore more of these examples as well as finding some equations of tangent lines. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.